Hello, we're going to do a quick tutorial on GeoGebra 2D to make a funicular. Uh, the idea that you will have to do is set up forces that are dropping vertically. These are vectors, gravity, so vectors is pointing down. So on the input bar down here, you could just say, for instance, force 1 is 120 or something, force 2 is 100, and force 3, doesn't matter, let's say is 50. Okay, so now we have on the algebra window 3 different forces. These could be hundreds of thousands of pounds, so we'll need to scale that vector to make it fit on a page that's comfortable here. So we could set in a slider in here if we'd like to, and we could call it force scale, for instance. And the slider can go from 1 to, I don't know, 1,000. It doesn't really matter here. We can move it around here. And then I will need a parallel line to this y-axis, and I'm going to drop it down somewhere over here. It doesn't matter where. So perpendicular lines, parallel lines are all over here. So we'll do parallel line to the vertical axis and just drop it here. Now I want to create a vector that's dropping down on this axis. The easiest way that I know of doing that is to do circle with center and radius. Circle with center and radius. And that would be, the first one would be force 1 divided by force scale. And I think my force scale needs to be changed here. And then I could, make it comfortable. It doesn't matter what it is. And now I need this intersecting point down here. And the intersect is, easiest is to use this button here, intersect. So you touch the one item and the second item. And obviously there's 2 intersects here, but we don't need the 12 o'clock. So just don't delete it, but just say we won't show it. And then to be kind of slick, we can add a vector here and go from the center to there. And then hide the circle, don't delete it. So now we have our first vector, which would change with the scale, and then change obviously with the magnitude of the force. So on for the second force. We start at the end of the first arrow, and that would be force 2 over force scale. And do the same thing with the intersect, the first entity and the second entity. And I could hide that 12 o'clock if I like, just to avoid confusion. Hide the circle itself, and then put another vector on here, just for looks. And then the third, I'm going to change my force scale so it's a little bit more visible. Center and radius. The third one would be force 3 over force scale. And another intersect of the first entity and the vertical line. And again, I could hide that point and hide the circle, and then put a vector in here. And now I could hide that whole line because I don't need it. Don't delete it, just hide it. So now this is a force diagram, the 3 forces. And suppose I have a chain going from, doesn't matter where, I just put a point. You could just drop a point here, it'll snap. Let's say it's 16 feet long here. So I'm drawing the form to full scale, but the force had to be changed by the force scale. So say the chain starts at one end and goes to the other end. Here for me it was 0 to 16. It doesn't matter. And now the most confusing thing for students is the pole. The pole is a mysterious object. I will show you what it means. I'm going to drop it on the right side of the load diagram. It doesn't matter where I drop it. And I'm going to put segments from the tip of each, from the end of each vector to the pole. And notice that, escape, Control Z. Notice that if I move the pole, all those segments are tied to it. And now here's the tricky part. Where are these forces on the chain? Let's just suppose that they are at 3. We could do 3, 6, and 9, but let's just change it a little bit. Let's do 3 and maybe 7 and 13. It doesn't matter really where. So I'm going to pretend that that first load is on here, the second load is here, and the third, and the chain will be piecewise linear under those loads. So I'm going to do a parallel line to the first segment, starting at the left end of the chain. And now I need to find where that intersect happened, because I put that first load at 3, for instance. Easiest way to do that is just another set of parallel lines to the vertical axis. So a parallel line from here, snap that to that point, to there, to there. And let's put one on the end also, and you'll see why we need it there. So we have these kind of ugly lines. We'll clean them up later, but I'm looking for this intersect point. So here's the first one, this to that line. And now I could hide this line. Don't delete it, hide it. I can hide this line. And now I could put a segment in here. And what you'll see is, if everything's working correctly, if everything's working correctly, is that, Control Z. Okay, so if everything's working correctly, then when I move the slope of that line, it will move the slope of that segment if I move the pole. Okay, so now I've got the second segment, parallel line to the second segment, parallel line, so this line, this segment, excuse me, and snap to here. That's why I needed that point. Now I need the next intersect. Here and here, boom, we're done. You could hide both of these, don't delete it, hide it. Show object, and then put a segment in here. And now the third segment, and notice there will be 4 segments for 3 loads. Third segment, and an intersect here. It's actually quite mesmerizing. I think it's like knitting, but I don't know how to knit, so maybe that's not true, but there's kind of something meditative about this. I'm going to hide this. I probably shouldn't talk and do GeoGebra. And the last one. So the last one will be this last segment. And notice now that's why I needed that last vertical line, because I want it to end here, but it might not have ended there. So I'll explain that in a second here. And I'm going to hide this line and another segment. And then finally I'm going to hide this line. So what I really want to do is have the chain hang from 0 to 16, but to drop on that same horizontal elevation. So I just simply move the pole until that aligns. Okay? And that's the hanging chain. The great cool thing about this, of course, is that it's parametric. So if I change the load, for instance, to be 200 for that second load, boom, everything changes and the shape of the chain changes, right? It makes sense that the second load was 200, so it's a lot heavier. And then the crazy cool thing here is that I could just flip the pole over to this side, and ta-da, I have a perfect shape for those 3 loads. So this is a funicular for these loads. A funicular is always for a given load. But notice the other nice thing here is that even for these given loads, I can arbitrarily change the elevation of my shell. I can make it very shallow, very, very shallow. But what that means is that my forces are increasing. Remember, this is the representative of the forces. So now I have these crazy large forces for a shallow shell. Or conversely, I can have very small forces. Here's a very small force for a very tall shell. And that's it right now for tutorial 1. Thank you.